Okay, number 6, lesson 6-4, page 338. It says complete the table for an investment if interest is compounded continuously. So our formula we want to use for continuously compounded interest is your amount, A, equals your initial amount, A sub 0, times e to the RT. R is going to be your interest rate as a decimal. T is your time. It's kind of a two-part problem. They tell us that the initial deposit is $2,000 and that it takes 15 years for that money to double. So our initial amount is going to be $2,000. And our time is going to be 15 years. Put a 15 in for T. If the money's going to double, how much would you have after that 15 years? 4,000, sure. So we start with 2,000. After 15 years, we're going to have $4,000. What we want to do is find our interest rate, R. So what would I do first? Divide by 2,000. Good. Divide by 2,000 on both sides. 4,000 divided by 2,000 would be 2. So you get 2 equals e to the r times 15. Let's just call it 15r. Trying to solve for r, what would be the next step?
Natural log.
Take the natural log on both sides, because a natural log will cancel out an e, because they're inverses. Inverse operations. So you move this 15r. Now that you have a logarithm, the logarithm rule says you can move that 15r out front. So you have natural log of 2 equals 15r times the natural log of e. But what's the natural log of e equal? 1. So you're timesing by 1, so I'm not going to put that down. What's the last step here? Divide by 15, right? So you divide by 15. Your interest rate comes out to the natural log of 2 divided by 15, which is 0.0 something, I bet.
462.
0.0462?
Yep.
Do you have any more decimals?
09812.
Okay. So our interest rate, if I move my decimal 2 to the right, about 4.62%. Okay? So if you have $2,000 and it's compounded continuously at 4.62%, you'll have $4,000 after 15 years. Okay, so you can double your money in 15 years at this interest rate, compounded continuously. All right, again, this is number 6. Let's do part 2 now. Number 6, part 2 says they want the amount in 30 years. So that's not going to be difficult, because all you need to do now is go back, use your interest rate. Here's our formula again. A equal A sub 0 times e to the RT. And it wants to know the amount after 30 years. So just put in your $2,000 starting amount times e. Your interest rate, let's use this entire decimal. That way we'll make sure we get a really accurate answer. 0.0462 09812. And what should I put in for t for time? 30. So now it's just a matter of taking 2,000 times e to that power. Now you do want to make sure you put parentheses around your exponent so that the calculator knows that that entire amount is supposed to be in the exponent. That's the only thing that you have to be careful of here. So we're going to type in 2,000 times e, which is second divide, to the power of, and then in parentheses put your decimal, 0.0462 09812 times 30, enter. We rounded the nearest penny, that would be what? $8,000. So at 4.62% interest, compounded continuously, after 30 years, you're going to have $8,000. That's part 2 of number 6 on lesson 6.4. Any questions about that?